Alright, good morning everybody. Today we are going to be working on your Quiz 10 study guide. And let's see, this is all classes and 4, 8, 20. So here we go. And what I'm going to do is I'm also going to post a study guide on Focus that will provide you more practice problems that looks just like this study guide. So you're going to have this study guide that I'm going to do as a video. Then I'm going to post another study guide that has the same type questions with different numbers. And then I will post your quiz on Thursday morning like we normally do. So that assignment on Focus that says study guide, it won't count towards your grade, but it's just a way for you to get a little bit more practice. So here we go. Number 1, finding the value of x, if necessary, round to the nearest tenth. Figures not drawn to scale. We've got a tangent and a secant, and our rule says that the tangent squared is going to be equal to the entire secant, which is 9 plus 17, times the outside portion of the secant, which is 9. So if we just work through the math, our x squared is going to be equal to 26 times 9. So our x squared is going to be equal to 234. And if we find the square root of both sides, then our x is going to be equal to 15.3. And there we go. Alright, problem number 1 in the short answer. AB is tangent to O. If A to O is 12 and B to C is 25, what is AB? So we're looking for A to B. So in this problem, if A to O is 12, then O to C is also 12. And what we're going to do is we're going to extend BO to the back of this circle. And when we extend BO to the back of this circle, what we have is a tangent and a secant. And we can use our tangent and secant rules to solve this problem. So if C to O is 12, then O to C is also 12. So our tangent squared is equal to this entire segment, the entire secant, which is 25 plus 12. I'm sorry, it's 25 plus 12 plus 12. So that's 25 plus 24 times the outside portion of the secant, which is 25. So our AB squared is going to be equal to 49 times 25. AB squared is equal to 1225. And if we find the square root of each side, AB is going to be equal to 35. Alright, number 2 in this short answer. AB is tangent to circle O at point B. Find the length of the radius R for AB equals 7. And A to O equals 8.1. A to O is 8.1. Round to the nearest tenth if necessary. So what we're trying to find here, find the length of the radius R, we're looking for this piece right here. Alright, we could extend this and we could do a tangent and a secant, but here's the shortcut. When a tangent, or the tangent to any circle, when a tangent intersects with the radius of a circle, it forms a 90-degree angle. So what we've got here is a right triangle. And in this right triangle, we're trying to find the length of r. So what we got here is a Pythagorean theorem problem. We can say that 7 squared plus r squared is equal to 8.1 squared. So we've got 49 plus r squared equal to 8.1 squared, which is 65.61. And if we subtract 49 from each side, then our r squared is equal to, let me get my calculator out, 65.61 minus 49 is 16.61, and if we find the square root of both sides of that equation, 4.07, or our r is equal to 4.07 to the nearest tenth is going to be equal to 4.1. Alright, problem number 3. The radius of circle O is 28. So here's our radius of 28. O to C is 9. Find A to B. Round to the nearest tenth. If necessary, the figure is not drawn to scale. It's another right triangle problem. If you extended this OC to the edge of the circle, it represents a radius. And we talked earlier in the year about a radius or diameter that intersects with a chord. When a radius or diameter intersects with a chord, it creates a 90-degree angle, and it bisects the chord and the arc. So if we find this segment right here, we can double it to find A to B. So we're going to call this x. So 9 squared plus x squared equals 28 squared. If we subtract 9 squared from each side, then our x squared is going to be equal to 703. And if we find the square root of each side, then our x is going to be equal to 26.51. And when we double that and we round it to the nearest tenth, our x is equal to 53. Check that. If our x is equal to 26.51, we have to double that, so our A to B is equal to 53. Alright, problem number 4, we have two chords intersecting inside of a circle. So we said earlier in the week that the product of their segments are equal. So we've got 10x equal to 9 times 15. So our 10x is going to be equal to 135, and we can divide both sides by 10, and our x is going to be equal to 13.5. Problem number 5, we have two secants intersecting outside the circle at point A. So our rule is the entire secant times its outside piece equals the entire secant times its outside piece. And if our A to B is 15 and our B to C is 10, then our A to C is 25. Our C to D is 6. So what we've got, the entire secant is equal to x plus 6. This right here is x plus 6 times the outside portion, which is 6. And that's equal to the entire other secant, which is your 15 plus 10, times its outside piece, which is 10. So on the left-hand side, when we do the distributive property, we get 6x plus 36. And on the right-hand side, we get 15 plus 10 is 25 times 10 is 250. So if we subtract 36 from each side, then 6x is equal to 214. If we divide both sides by 6, then our x is equal to 35.7. Alright, in problem number 6, figure consists of a chord, a secant, and a tangent to a circle, round to the nearest tenth if necessary. What we've got to do first here is we've got to solve for this piece. This segment of a chord. Because we've got a tangent and a secant, there's a rule that applies that we can find the value of y. Once we know the value of y, we can find the value of x by our rule that relates to chords intersecting inside of a circle. So the first part of this problem is we're going to take this tangent, 15 squared, and we're going to make it equal to this entire secant, which is y plus 7 plus 9. So that's y plus 7 plus 9 times the outside portion of the secant, which is 9. So 15 squared is 225, and that's equal to 16 plus y, or let's just keep it as y plus 16, times 9. So when we distribute this 9, our 225 is equal to 9y plus 144. If we subtract 144 from each side, then 81 is equal to 9y, and we can divide both sides by 9. So 9 is equal to y. Alright, number 7 is a straightforward tangent secant problem. Find the diameter of the circle for B to C. B to C is 16. D to C is 30. Round to the nearest tenth. We need the diameter. So we need this portion of the circle. So we are going to call the portion of that portion of the circle, we can call it BA. Excuse me. Alright, so what we've got here is the tangent squared is equal to the entire secant, which is BA plus 16, times the outer portion of the secant, which is 16. So 900 will equal BA times 16 is 16 BA, And 16 times 16 is 256. So if we subtract 256 from each side, then 644 is equal to 16 BA. And if we divide both sides by 16, and we round to the nearest tenth, then 40.3 is equal to BA. Number 8, we need A to B, the outside portion of this secant. So again, we're using our tangent and secant rules. So our tangent squared is equal to the entire secant, which is 15 plus AB, or it's AB plus 15. Okay, this is AB plus 15 times the outer portion, which is AB. Alright, so here we go. 25 is equal to distributive property. AB times AB, that's AB squared plus 15 AB. And if we subtract 25 from each side, zero equals AB squared plus 15AB minus 25. And this presents us with another trinomial problem where we have to use the quadratic formula to solve for AB. So in this case, AB is going to be equal to, and let's kind of put this in perspective a little bit. What's in front of the AB is your A value, so that's a 1. What's in front of the variable is your B value, so that's a 15. And anything to the right after that is your C value, so our C equals negative 25. So you've got the quadratic formula in your notes from Tuesday. So our AB is going to be equal to negative 15 plus or minus the square root of 15 squared minus 4 times A times C, which is negative 25. And we're going to divide all of that by 2 times A, which is 2 times 1. So what it boils down to is AB is equal to 15 plus or minus the square root of 325 divided by 2. So when we do our AB plus the square root of 325 divided by 2, we get an AB value of 1.5. And when we do our AB is equal to, this is negative 15. Negative 15 minus the square root of 325 divided by 2, we get a negative 16.51. So since we're talking about the outside piece of this secant, it's not going to have a negative value. So we're not going to use this value, and our AB is equal to 1.5. I've done this problem a couple times. This negative 15, be very careful. When it's the opposite of B, okay, plus or minus, be sure that you carry that negative sign with you. Okay? Be very, very careful. Alright, number 9. A chain fits tightly around 2 gears as shown. The distance between the centers of the gears is 20. So this is 20, the center of the gears. The radius of the larger gear is 11. So here's 11. Find the radius of the smaller gear. Alright, let's call it R. Now, we said earlier that when a tangent intersects with a radius, it intersects at 90 degrees. So here's what we've got here. We've got two 90-degree angles. And if we have to find the radius of the smaller gear, what we're going to do is we're going to take this 19-inch side that's parallel to both radiuses, and we're going to slide it down. Okay? And we're going to slide it down to here. And when we do that, a couple things happen. It stays 19 inches, and this angle right here stays 90 degrees. Okay? So now we have two sides of a right triangle. And if we find this piece right here, we can subtract that piece from 11 and we can get this radius. Okay? So we're going to call this, for right now, I'm just going to call this y. So using the Pythagorean theorem, y squared plus 19 squared equals 20 squared. If we subtract 19 squared from each side, then y squared equals 39. If you find the square root of each side, y is equal to 6.244. Okay? So that's that little portion right there, right here, is 6.244. Well, the radius, okay, the radius is the difference between 11 and how far you slid this down. So our radius is going to be equal to 11 minus the 6.244. So our radius in this case is going to be equal to 4.8. And number 10 is a very similar setup. BC is tangent to circle A at B, so this becomes a 90-degree angle. And circle D at C, so this is also a 90-degree angle. A to B is 10. B to C is 21. And D to C is 8. Find AD to the nearest tenth. So we need the distance between these two gears, spindles, tires on a bike, whatever they are. So we're going to use the very same principle. Alright? If we have a segment that's perpendicular to two other segments, if we take this B to C and we slide it down until the right side hits point D, then this segment is going to look just like this, and it's going to be perpendicular to AB as well. It's still going to be 21 units long, and we need to find this distance. So if you see right here, what we did was we slid this down 8 units. So if it was over here on the left, if it was 10 to begin with, and we slid it down 8, it is now, this piece right here is now 2. units long. So we have another Pythagorean theorem problem. We've got a leg squared plus a leg squared equal to the hypotenuse squared, AD squared. Alright, so our 2 squared plus 21 squared is 445 equals AD squared. And if we find the square root of both sides, then 21.1 is equal to AD. Alright, and that concludes your Quiz 10 study guide. Again, like I said, I will post a study guide to focus that will serve as practice, and then I will post Quiz 10 to focus on Thursday. So enjoy your 3-day weekend, stay safe and healthy, and I'll see you, I won't see you, but I will talk to you again on April the 13th.